Welcome to the city and the sea. Latvians do clap. Yay! That's so awesome. So today we're gonna see the final pitches from the teams who have spent 6 months preparing for this. No pressure, but don't give crappy pitches. I'll be watching and asking questions. We have 2 tracks. So there was the agenda there. We have the sea track and the city track. So with some, let's call them bio break in between. So yeah, starter presentations, mobility and water. Each pitch is going to be around 5 minutes, and then there's, I will ask questions, you have an opportunity to ask questions. And then, after pitching part, we will have discussion with, about research, testing, and commercialization in Latvian startup ecosystem. So the whole event, as you might have noticed, happens in English, but discussion part will be in Latvian. All right? Woohoo! Yeah. So, and then we will get back to the networking and demonstration. Probably feel free to grab some water, coffee, and snacks over there. And we have some additional opening words from investors, right? No? Then we... As a host, like, yeah, you have spent 6 months working with these companies, so.
We actually have 3 hosts, and first was supposed to be Talis Video from Riga Technical University, and then I was supposed to be next, and then Iveta was to be the third one. Talis, roll the video.
Hello, everyone. It's a great pleasure for me to welcome everyone to this exciting demo of the City to the Sea Accelerator program. Today, we are going to witness the result of extraordinary efforts of each of the Accelerator program team members, which have put to develop innovative solutions to the fight of variety challenges that is important for us and will help us to tackle challenges of environmental sustainability in water and city environment. During these 6 intensive months, we have seen tremendous growth of the teams and their solutions. With the help of high-level local and international mentors, teams pushed themselves out of their boundaries and tried to get the maximum out of the program. Despite the fact that 6 months is quite a limited time to succeed in that business innovative process, we have witnesses how teams created their new solutions, pilot them within the real life environment, and even have negotiated the industry partners with their aim to establish long-term business cooperation. As a member of United Nations High-Level Expert Group, I would also like to highlight the importance of the work we jointly are doing together. Well, as you know, innovation is something which is going to change the future. So therefore, your solutions, which are very close to the market on one hand, but very innovative on other, is the way to go. So I would like to encourage all of the teams to continue to work hard on ideas and even dreams behind your solutions, because they are 100% in line with the long-term needs for the global society, and there will be demand for these solutions in future. Last but not least, I would like to thank all organizers who have made this program happen, colleagues at the Science and Innovation Center, Innovation Movement VEFRESH, Investment and Development Agency of Latvia, and many others who have provided great support for these 6 months. This backup office work, by providing support for our teams, is as important as creating the new solutions. I'm looking forward to seeing each of the team's brilliant projects and ideas in action. Good luck.
Thank you. Thanks, Riga Technical University. Thanks, Talis. This is our turn. There are two components from this accelerator. In fact, the teams have been working more than 6 months. Some of the teams worked in a hackathon last year in May, and some of these teams started to develop their solutions back then in 2022, and now they're continuing to work in 2023 in our sort of more advanced and more supportive program of this second leg of our program. Why CT2C? We believe that all companies which are now facing the next decade will be climate companies. They'll all have to account of how innovative they are, but not only that, but also what is their impact in fighting the climate change. And we take this very, very seriously, both with the program as well as our mentoring. And we hope then that the products and services you will see today, previewed by the teams themselves, are on a way to do that. So that's number one. Number two, I think that it's great that we've had two components, both the city, which deals with mobility, and a C component, dealing with water innovation in general and solutions across the range there. And third is that I think it's a new page in a local ecosystem that we've been able to work with not only local but also international mentors, helping the teams to scale, helping teams to think about the product, helping teams to think about commercialization as well as marketing. And fourth, and perhaps the most important aspect here, is that, and we always say that it's an ecosystem effort. There is not a single player can help a team to grow. Not to mention scale their product and commercialize their product. That's why we have partners from Riga City Council. That's why we have partners from university that are able to provide help, especially teams are dealing with deep tech. And even more so, we also have representatives from commercial sectors, so private sector here in the building, which are looking for these potential leads to scale these solutions, both in water innovation as well as mobility. So we're happy that all parties are here. And last but not least, Latvian Investment Development Agency, I think, was very brave and ambitious to go forward with this project because at times there are quite a bit of challenges to go ahead with this kind of a project with 16 teams being supported for 6 months with 100% intensity. It's a project of a kind, I would say there are not that many to learn from, and we hope that this is going to pave a way for many programs to come along the way that could work not just in local but also Baltic context, which we think is important to the way. So thanks for the team, Leah, Dace, and Laura, and Iveta, and rest of you guys for believing into what we're doing here. It hasn't been an easy journey all the way, but I think that today the teams you're going to be seeing literally in a couple of minutes have been worth the effort, have been worth the ambition, have been worth the courage you guys gave us working with a team in Riga Technical University. And we hope that you guys will be active in sort of shaking up the teams with Q&A session. What do you think the teams need to go forward? Because again, we need all the optics, we need all the advice, we need all the guidance and recommendations from where you stand and how to grow that. So without further ado, we're happy to have both batches presented today. We're actually proud of what's been done. Myself and Igor have been chatting along a couple of months that we didn't even believe that all the teams that you're going to see here today will make it to the end. You know, it's pretty brutal out there if you guys work with startups, that most teams actually die. And it happens whatever the field you are, deep tech, fintech, or climate tech, most teams die and don't make it to the end. And we're happy to see that teams have made it this far, and they all have a prototype, MVP, working, a workable model. And we hope that they'll continue to grow for the next 6 months with the programs that are lined up in different sectors of ecosystem. So again, thanks to the teams, thanks for the team in Riga Technical University, Igors and Amanda, Aneta, and the rest of you guys. You've been doing fantastic work. This would never be possible with you guys. My colleagues at Vefresh, Valds, and Richards, who've been doing some heavy lifting. So thanks from Vefresh side over to Iveta and Latvian Investment Development Agency. Iveta, the floor is yours.
Hello, Demo Days participants, potential investors, and everyone who follows us online. First of all, I would like to thank our great partners from Riga Technical University and VFresh for organizing this great event. The venue is perfect, innovative and on water. And of course, thank you for your everyday work with us. And you were ready to face any challenge, to try to find solutions together with us on daily basis, and actually these challenges mostly were not connected with water innovations. Today we have 14 teams who will present us technology and science intensive solutions in the field of water innovations and smart mobility. And we're really pleased that practically from scratch, in a few months, we can see significant progress today. And new prototypes and potential products that fit perfectly into a social model focused on sustainability have been created. And on behalf of the Investment and Development Agency of Latvia, I can prove that we will continue to support programs like this one. And of course, we are ready to support ideas, products, companies which work in this sector. Well, I wish you productive presentations and ambitious goals for the future, and I hope that one of Latvia's next unicorns will likely take its first steps here today. Thank you very much.
So, we are ready to kick off the water part. We will start with the first startup, which is Algae Phos4X. Very scientific name, eh? From the startup mentoring point of view, keep it simple. Stupid. Sometimes we say KISS. But yeah, Algae Phos4X is a physical device, and I think it's out there, right? No, not this one. But the point is that they help remove phosphor from the municipality waterways. Please, video.
My name is Aigars. I'm a researcher at the Water Research and Environmental Biotechnology Laboratory at the Riga Technical University. With my colleagues from the laboratory, we have formed a team named Algae Phos4X. We develop new solutions and innovations for wastewater treatment, drinking water supply and its safety, and also innovations for resource recovery from different waste materials you can find all around the environment. Right now we are at the Water Research and Environmental Biotechnology Laboratory. This here is the pilot room where we install and test the performance of the pilot reactors that we are constructing here. We are developing a photobioreactor that could be used in operating for smaller villages, also at some production facilities like food processing plants. So the solution we develop is wastewater post-treatment system based in microalgae. So the idea is that we expose microalgae biomass to phosphorus stress to stimulate it to consume phosphorus at much higher rates than it would do at normal conditions. So the idea of this photobioreactor is that it consists of several vertical columns, and each column has a specific task. One column is hosting the phosphorus removal process, while in the other columns, microalgae biomass is exposed to phosphorus stress conditions at different stage. And then consequently, each column is taking over the task of the previous. So at the end, the biomass that is produced during the wastewater treatment process can be used for different purposes. It can be used as animal feed, soil amendment in agriculture, because it's high in the phosphorus content. From the microalgae biomass, we can also extract high-value molecules that can be used for food production, cosmetics production, and also as ingredients for pharmaceuticals production. Technology that uses microalgae for wastewater treatment exists, but it's not used at a full scale, or it's not a conventional technology for wastewater treatment. It's still experimental, and one of the problems that we are trying to solve is how to enhance the phosphorus uptake from wastewater. Normally, it takes about 2 to 3 days to fully remove all the phosphorus from wastewater. Our solution ensures that phosphorus is removed from wastewater entirely within few hours. As a team of scientists, we were focusing on the work in the laboratory, developing our solution, but we had very slight idea who is interested actually in this technology. During the City to Sea program, we did a market research and understood that wastewater treatment facilities might not be the right application for this technology. It should be something more specific, for instance, fish farms or breweries, or like beer production facilities, where the wastewater chemical content is very appropriate for high-quality microalgae biomass production, and it also ensures downstream processing of microalgae biomass that is produced during the process.
I think it's just great that Igor's innovation about algae goes in very close relationship with Europe Commission mission Restore Ocean and Waters by 2030. I think his innovation gives really nice input by investigating algae and their potential for removing phosphorus from wastewater. And I hope that Igor's example will be great opportunity to others be open for investigating algae and their potential in the future.
Our plans for the future is to go outside the laboratory and test this technology at relevant conditions.
Would love to see the reactor. Where's the team? Ah, you're over here. Come over. Show yourself. Scientists tend to be shy. Is it working? Yes? No?
Yeah, it is.
Cool. So, how was the 6 months?
6 months, well, the 6 months were quite intense. Well, we had to, I don't know, we'll try really hard to find time to dedicate for this project. Well, maybe not everything turned out as we expected, but...
Welcome to the startup world.
Yeah. You know, our very first experience with startups.
Great.
But yeah, okay, sure. Yeah, it is great.
Any questions from the audience about the reactor?
What have you developed during this program? Which part exactly?
Well, during this program, I can't say we developed something specific, but we had a chance to test this technology at real relevant conditions. Let's say before that we developed this technology at laboratory scale, but here we had a chance to scale it and to test it with real wastewater in real conditions as we imagine how it would work if it was installed in a real wastewater treatment plant.
So, what's next? What are the really next things you're up to with the...
Well, next now, at the moment, we are still working with experiments. Like we are, let's say, running this photobioreactor at relevant conditions, which means laboratory and real wastewater. It's no synthetic wastewater anymore. And we will continue doing that until maybe the end of the year, like to have long-term data on the performance of this technology. So that's important to have to convince the end user that, hey, this works in the long term. It's not just 1 week and then we have some assumptions that it might work.
So what are you looking for? Are you looking for money, talent, connections?
No.
How we can help you?
I don't know. Well, yeah, that's one thing that we were, well, as it was mentioned in the video, that we are laboratory people, scientists, but we know nothing about the market.
You need salespeople?
Salespeople, maybe do some in-depth market research to understand where to actually sell this thing.
You need someone to leave the cave and go out.
Yeah, exactly.
Yeah, exactly. So, okay, cool.
Yeah.
Thank you. It's actually a great opportunity for marketing and salespeople to join up with people who actually invent stuff. You saw that green reactor thing. It looks cool, but probably also does really cool things. But scientists, they are interested in, science. Cool. Let's move on. We have a next company, VLEG, or YLEG, producing energy in the sea from waves.
Hi, my name is Peter, and I'm from Institute of Solid State Physics, and I represent Team VLEG. Here we develop linear power generators, which convert wave power into electricity. Our solution is currently being tested, so we want to extract power from small waves and bigger waves, and if all goes well, also sea waves and ocean waves. Our technology is based on using linear generator, or in fact any type of generator that can convert linear motion into electricity. Not only waves move linearly if you convert them, but we also can use flowing water. Instead of usually turbines, we can use also linear motion in that, and we see that our electronics that we have now developed can harvest that power more efficiently than before. Here at Institute of Solid State Physics, during the City to Sea program, tested many of these prototypes and tried to create the most efficient way how to harvest wave motion without significantly limiting the wave size that we can use. For this device, we expect that the users might be municipalities first, as you might need a lot of them to generate significant power. But when the efficiency increases in next iterations, we might see uptake from the private sector, where you need to generate power for your own private island and yacht parked somewhere. During this program in City to Sea, I have seen big growth in our team. You see that we have electronics on it. We can actually monitor and record all data on site. We have made a bigger prototype, or multiple prototypes that can definitely define which is the way to harvest wave power from small waves and from bigger waves, especially thinking about Baltic Sea region. If we go to Taiwan, we can harvest 14-meter waves. We need big floats and things. Here, locally, we need smaller floats, smaller power, and especially hard it is for freshwater sources. Freshwater has smaller density. This is what we have investigated. Also, during the accelerator, we had great experience with lessons that we had from 2 dots. From these interactions with other teams and our mentors, we gained understanding how to approach problem of expensive tech and market needs. And it usually combines in very specific sectors. And those sectors can be point extractors for ports that we see as an interesting topic for us especially. We see also that piers can be some place that we can put these generators on. And we also see that we might in fact go in another direction completely out of sea into flowing water. In the City to Sea program, we found the capability to talk to Free Harbor of Ventspils. And we think that that might be a possible location to prototype, to actually have prolonged tests in sea or freshwater environments. Here in Riga, we don't have such strong winds and wave regimes as we might need to have good tests for development of the product. Then in the Baltic Sea, or closer to the Baltic Sea as in Ventspils, we see that that might be a great thing to come out of this program.
Team? Oh, here you are.
Thanks.
Yes, welcome on the stage. How do you feel?
Very well, thanks. Yeah,
Good.
Thank you for inviting us. Thank you for supporting. There's another team member there hiding. Yeah.
Pointing out team members.
Yeah.
So, let's go really practical.
Okay.
What can I charge with the thing?
probably someone a lot of money. With that thing, you can charge capacitors. If you have them in series, like if you would have 15 of them, then you probably could already charge a phone. And then there's a bit of electronics that need to happen so that you can charge a 12-volt battery and then use it to something more useful. But as with power electronics, there's a lot of conversions that need to happen, and efficiency is hiding there.
Yeah, losing some energy on the way. So
probably.
Yeah. So what's next?
So I think I already told everything, but maybe not entirely understandably. So yeah, we are still performing experiments, as the previous team was saying, and we are building a version that I couldn't show due to hopefully patenting possibility. So we are going into flowing water as in streams, so out of the sea back to the city. And those streams can still generate, if you have a water drop of a couple of meters and then good flow of at least a bucket of water, you can also set up a generator there, which is a small generator, but still more efficient than working with 10-centimeter waves. So if you have flow, then we have a solution that would be very interesting for you. Yeah.
That's a good slogan. If you can flow, we can extract energy. Any questions from audience? Yes.
Yeah, so yeah, very good and
tricky questions.
Tricky questions. Depends where your house is. If your house is on the seaside, then probably it's a cable to the generator. If your house is far away from the shore, then you have to decide how much electricity do you need. A standard house needs about 3 to 10 kilowatts, depends are you doing the bare minimum or are you in the US. 10 kilowatt station would be multiple floats like this. This one probably is in the range of 200 watts, 500 watts, depends on, again, on the floats. As you saw in the video, we were working with below 10 centimeter waves. That doesn't charge anything, almost anything. Like you can get the voltages, you can't get the amperages. If you want significant power, you need to go to at least half-a-meter waves. Half-a-meter waves are set in certain places, and you have to take a look, is your house located at the place where you will have most of the wave regime that you have? If your house is set to the stream where you have a drop of at least 1 meter per 10 meters, like a small stream, then we can do another thing. But again, that won't be like a huge solar park. It will be a point extractor, yeah.
I'm thinking about such places in Latvia. So here's the microphone. Yeah.
Yeah, I have an idea, suggesting that you could test it in Lutsausala, because in Lutsausala we have a lot of family small gardens, but there is no electricity actually, and then there is a river from both sides, and
yeah, we would very much like that. The problem is that usually you have to be allowed to put things in a water, and there's certification involved with that. And if you can allow us to put floats without certification, we're up for it. Yeah.
Oh, yeah. Well, let's make it happen, Riga City Council, right?
Yeah. Just allow us, and we'll do it.
Cool. All right. Thank you. So let's move on. So we can expect that, right? Yeah. Yeah. Riga City Council having skin in the game. That would be nice. So let's move on. Ship's waters for future. So cleaning wastewaters on tankers. Next.
We are shipwater researcher from Latvian Maritime Academy of Riga Technical University. Plastic filter idea comes from pollution prevention technology from ship waters as wastewaters and other types of pollutants.
Plastic Trap filter is microplastic filter that collects microplastic from wastewater. And our product is the best available because we use waste from leading companies as Latvijas Finieres and Malmere Glass in our product that are in the absorbing and in filtering materials. Also, our startup has thought about what to do with the microplastic that is collected. There is no worse scenario than collect microplastic and put it in your waste bin. Also, our absorbing materials are made by new eco-friendly technology that is developed by the Latvian State Institute of Food Chemistry. During this program, we have gained a lot of new knowledge, and we have improved our team competencies in problem-solving, communication, and establishing contacts. Mentors of the program led us to new rails and showed us how technologies that are developed in laboratory can be commercialized. Also, during the program, we had our learnings that will help us grow and do things differently. The microplastic filter will be developed further for land-based wastewater technologies and households.
Although the product will be developed to be more user-friendly, more effective, and more ecological.
Team? How hard is to add that filter to that ship?
To the ship, it's much harder than to the land-based, some facilities, but it's always an option.
But you're pitching that it's for ships.
Yes,
so
it's not only for the ships. We're looking forward to land-based treatment. But also, of course, our idea started with the ships because we're coming from Latvian Maritime Academy. That's our background. That's our alma mater. So idea developed from wastewater treatment on the ships. So yes.
Cool. So what's next?
What's next? We're looking forward to develop our absorbing materials that you already saw there, and you can see also there behind you. And so we're going to develop the absorbing materials. We're going to look forward to land-based wastewater treatment systems and also washing machine systems. And of course, we're open to some partnership.
Great opportunity.
Hello.
Who are you looking for?
We're looking for definitely someone who's not scientist, you know. That's enough. We have our partners in this field. Maybe we're looking more forward to some marketing.
How many marketing people are here?
And maybe some more pessimistic people, because we're very optimistic, you know. We are really believing that our solution will help to prevent the microplastic in the environment. So if someone is pessimistic and works in marketing field, come.
Pessimistic marketing
with us.
people. That's an. Is that unicorn exists? I don't know. So, any questions from the audience? Anyone who has some wastewaters and needs some filtering?
You know, probably when there's no question, usually
Eva?
no one understood.
Well, this was straightforward. There's like wastewater and filter. We make filter.
Yes,
So,
a question.
So you said that you have solution what to do with the microplastic afterwards. So what that would be?
Yes.
throwing away.
Yes. As I already said in the video, there is no worse scenario if we just collect the microplastic and then again we just kick it out to the waste bin. then there's no logic in that. So we're gonna recycle it in the new materials, where we can combine different materials also that are in our absorbing material and this microplastic. So again, this is about more ecological thinking and about green thoughts about the future, you know.
So you're getting your part done, and then you're looking for someone to do the next part.
Of course, of course.
Cool. Great. Any more questions?
Nah.
Marketing people?
Nah.
Shy, pessimistic
to
marketing
shine.
people? All right, let's move
You
on.
know, it's
Yep.
always can be a multi-million deal, so don't forget about us.
I like the optimism.
Right?
Yeah, that's the spirit.
Okay.
Cool. Thank you. So, let's move on. Next up, submerged Baltic. So, analyzing water, we probably are used to that someone picks a sample from the surface. Submerged Baltic is about analyzing deep water. So, off to submerged Baltic.
Hi, my name is Carlos and I am from Submarine Baltic. We are a team of two working on submarines. Our solution is unique in Latvia and Baltic states because it's first torpedo-shaped submarine in the Baltic. Our product is unique because we adapted for Baltic states. Baltic states has turbid waters, and what we are trying to do, we are trying to solve this problem. We are using special lights to increase the visibility, and even better, we are using special software for image real-time enhancement. Our submarine is torpedo-shaped, which allows it to reach greater speeds and efficiency. It has 4 motors, which gives it a reasonable maneuverability. Submarine knows its exact location using DVL and ENS. It has a designated payload compartment, which allows it to equip with different kinds of sensors, for example, water quality sensors. It has capability to use multiple cameras, for example, in front of it and in middle of it. Right now, it has a working time of several hours, but it has a special compartment which can increase battery capacity to several days. Submarine can be accessed from anywhere around the planet using buoy and 4G internet. Our product is cheaper than our competitors, and it gives the same result, or even better, we can adapt our product to a specific customer to give them the result what they want. For example, we can make underwater 3D scans, what's really useful for ports. In City-to-Sea Accelerator program, we gained a lot. First of all, we gained confidence. Right now, we know what we are capable of, and we know the clients want us. Secondly, we got a financial support, which gave us a great opportunity to purchase expensive sensors. And thirdly, we got a unique opportunity to work with one of the leading mentors for startups. And lastly, it's very inspiring to see that other teams are working on water solutions. During the program, we acquired investment by Build It, which allows us to make MVP. And even better, we can deliver our product faster to clients. We are planning demonstration with police after a few weeks, and they are planning to buy our product. They intend to use it for search and rescue operations.
Cool. And I don't have to invite them, they are jumping on the stage. So probably not scientists. But
that's true.
Yeah, the first question is like, let's take away every sensor, how much the thing costs?
If you want to pay us something, it costs like 15,000 euros. So
15,000?
Yeah, it's cheaper than competitors. So normal price is like 27.
That's
or 30.
without sensors and anything.
Oh yeah, of course.
I just had GoPro and have some fun, right?
Oh yeah.
Oh yeah.
But
yeah.
we will have some client used submarines that will cost a lot cheaper. So after a few years, you could go inside your local RIMI and buy your submarine for like a couple of $1,000. So that will be fun to
In
use.
Rimi. Okay.
Not in Rimi, but yeah.
Cool. Yeah. So it goes beyond water analytics. You are already mentioned the police. Cool. How many orders?
We don't know yet. But we will have demonstrations with all the internal structure, with the National Guard, with firefighters, with police, with I don't know, even like special forces or something like that.
Okay. So that basically are your next steps, right?
Yes, exactly.
Okay.
After a few weeks, after the Songfest.
It's always at the pitching events. It's just like after this event, couple of weeks, the big stuff gonna happen.
It's like 2 months like this. So.
Yeah.
Yeah. Always a few weeks.
Yeah, always few weeks away is the big thing. The thing is coming.
Yeah, it's easier.
Yeah.
That way.
You see, again, positive people. So, any questions? Yeah?
Yeah. What would be the main applications in which field? Business, municipality, ports, industry. What have you? Yeah, where we would use it most, or what your competitors where they sell it?
It depends on the competitor, but firstly, we want to get in the B2G compartment. We want to sell it for our government, mainly in the first steps. After that, we want to adapt our product to industry for ports. Competitors sells it, for example, Norwegian company sells it to their local armed forces, to Naval Guard. But the problem for us, we lack the money and we lack the capacity of the Naval Guard, so we need to adapt it to our solution, so our market.
So basically that's a platform and it has multiple.
Exactly.
Okay.
So we will use it, as I said, for ports and for police. And for police, it's like rescue and save operations, but we want to give it added value to scan the surroundings. For example, as you can see, the shorelines, they need to be maintained regularly and they need to be scanned. And you need to give some kind of engineer signature that they are safe to use. So we want to get in that field.
Cool. Are you doing live demo today outside?
Yes. After the demonstrations, we will have a demonstration with our colleagues from IRF. So yeah, you will see. And I think maybe we can allow them to test it, to drive a little bit.
We have one more question from LMT.
What's your deepest dive?
1 meter. Right now.
Very long, very long cable, but just...
Oh no, cable is 25 meters, so it's not deeper than that, but we will try to reach the bottom. It is possible, but we have some problems as startups. I will explain it after the...
Off the mic.
Yeah, off the mic.
Okay, I can imagine deeper, and it's gone. 15,000.
You can always pull it out by the wire, so...
Yeah, that's
you will
true.
have the prototype.
Then it's like, pull it out.
Yes. We have thought about everything, so we won't lose it.
So what are you looking for now? What do you need? Money, partnership, short?
Right now, just time.
Just time. 2 weeks.
We have investment, we have money, we
Nice.
have, we just need to work on it.
Go get them, Tiger. Thank you.
Yes, thanks.
I think entertainment industry is a really big opportunity there. So, next up we have Pero Solutions Lab. I tried to summarize this one, but it was hard. Surface fixed dope TiO2 photocatalysis obtained with plasma electric oxidation method for wastewater treatment and corrosion protective coating. We'll see. It can go either way.
We
We are PU Solutions Lab team established in early 2023, and our know-how is to obtain coatings by anodizing, plasma electrolytic oxidation, chemical precipitation, and spray pyrolysis methods, as well as to obtain layer-type coatings to improve the properties such as protection against corrosion and mechanical damage, micro-hardness, and thermal conductivity of various lightweight materials.
During this project, our team has developed new method to obtain a surface-fixed titanium dioxide photocatalyzed on sheets of titanium. We have increased the area of our photocatalyst to 100 square centimeter, and we have developed system for photocatalytic degradation of organic pollutants. The main advantages for our photocatalyst is that it can be used under the sunlight, and it can be easily removed from the system. We can work with phenol containing wastewater. That is very important for pharma industry and also woodworking industries.
One of the biggest benefits of the City2C Accelerator program, apart from funding to develop our prototype, was the opportunity to participate in really high-quality trainings provided by the 2DOTS team, and a special thanks goes to Priya Manis, who not only shared her impressive knowledge, but also her contacts that helped us to hold talks with European Space Agency materials experts, potentially opening the doors to the space industry.
For me, as a scientist, it was interesting to learn about various business-related aspects and how to develop our business model. Our plan for the future is to develop a method where we can use our photocatalyst to degrade plastics and to obtain hydrogen and other important for energetics gaseous products.
Our main target is to conquer the transport industry. We see that our surface treatment solution has a great potential, as weight reduction is one of the main challenges in the transport industry to further reduce costs, fuel consumption, and therefore CO2 emissions. Our coatings will be able to offer the industry various material alternatives with improved mechanical properties to achieve the goals of cleaner, less polluting transport. So yeah, therefore our target is to unlock this potential and become an important part of space, road transport, aviation, and shipbuilding industries.
What can I say? Very good. So there's this game sometimes people play at startup events. So here's the game what that startup events people play. They do reverse pitch, which means like let some other people pitch what they got from your presentation. Let me try in short. Some talk about chemistry and materials, and they increased this big thing to this big thing. But they are working, soon will work with the space agency, but also with the transportation. And then they do something with the microplastic, but then they will change the transportation industry. Something like that. Not bad even. So, but let's go back to the basics. What would be the first application? Like really, like where can I use that thing and what will happen?
Actually, we can...
The microphone.
Thank you. Actually, we can split our tasks, our ideas in two parts. The first one is we produce coatings on various metals. In this case, it was titanium, and we obtain photocatalyst. This is the second part. Our photocatalyst can use sunlight, and we can purify the water, no matter 1 liter or even a cubic meter. It depends on the area of the metal we coat. And our photocatalyst is quite active. It can split real wastewater up to 10% per hour.
So that's a material which helps to separate clean water from wastewater?
No, we put it in wastewater, and then we gain back pure water outside. So we remove phenol from the water.
Okay, cool. Who can use that?
We have a company, big pharma company in Riga. I will not tell the name because it was asked by the company not to do that. But the amounts of phenol they produce is very high. It can be hundreds of cubic meters per year. And right now the solution for them they are doing as a water treatment is just to dilute it with water, and in small portions they just put in central wastewater system.
Okay, so they got an opportunity to clean before they put it in the...
Yep.
Okay.
Yep.
Cool.
And
Okay.
the second part of the application we are doing, we are making coatings. And one interesting thing is that we can also protect the metal we are coated with our coating against corrosion. And we are working in cooperation with various projects, and we can cover in such way aluminium, titanium, also zinc, and zirconium as a metals.
Okay, cool.
So, and those metals are important for transport and aviation.
Yes. Got it. Okay. What's next? Next 6 months, what's the plan? What do you need?
Yeah, well, within the next few months, we will receive the bipolar power source unit, which will allows us to conduct the tests and to provide them to the European Space Agency materials experts, and also for the project purposes as we pass through the first phase in the Green Offshore Tech project call. And then our next in the next 6 months, we will like to receive the funding through some funds. We have identified one, and to upscale this power source unit.
Okay.
So we'll be able to work with the industry.
Thank you. We have time for one question. Audience? Oh, well, no questions. Apparently everything is clear. So, thank you. They probably are looking for marketing people. So, just saying. So, next up, algae tree. Yeah, you know, oxygen, really important for people. We're breathing. Doctors say that's a really good way to staying alive. So, when you work indoors, of course, smart buildings and everything, we need fresh air. And so, algae tree is making this artificial tree from algae.
We are Team Algae Tree. We are a group of 4 people. Me and Kate are co-founders, and we work together for around a year now. We have 2 advisors, Agnes, who is also co-founder of Spirulina Nord. They are cultivating microalgae. And we have advisor Eva, who gives her expertise in communication and PR. Regarding to prototyping, we have 2 great partners, Krish and Christian. They have a workshop space in Riga, and they are making the prototype from the hardware and from the software side. The idea of algae tree came to me a few years ago when I was working from home in the city center of Riga, and I didn't have the ventilation system, so I started to research alternatives how to improve indoor air quality. I came across microalgae and their promising ability to absorb CO2 and release oxygen more than trees or indoor plants. I saw that there are no solutions on the market yet, so I started to dig deeper. As algae tree, we started to tackle a problem indoor air quality. 90% of time adults spend indoor, where low air quality decreases productivity and is cause of illnesses in half of the cases. And to mitigate these risks, algae tree has created forest for indoor spaces. Well, it's in a prototype phase right now. From the technical side, there is an air pump that filtrates exhales of 14 people. We're targeting offices with poor air quality, and these early adopters are helping us to test product market fit and also prototype itself.
During the course of the program, our main goal was to improve the design flows of the existing prototype. We would like to express gratitude to the organizers of this program, as it allowed us to revisit the idea from various aspects, as well as specify the target market, evaluating the potential for the idea development, starting with the practical tasks from tutors, the commitment of our mentor Davids, and finally the contacts and sources of motivation gained during the program. The opportunities provided by microalgae are endless, and we're willing to explore them above just air purifying. Algae grow by eating CO2, so there's always the question of what to do with the leftover biomass. At the moment, we're using it as a great fertilizer for indoor plants. However, we're looking to expand on that to allow the algae to be safely consumed by humans, as it's known for its positive health benefits. Basically, what we're doing here is offering a farm-to-table solution right for your office. We're also exploring industrial use of the microalgae, for example, biofuel production and use in space, so we're quite literally reaching for the stars. We're looking to add more skills to our team, so if you're an engineer or an scientist, hit us up.
Nice. Kate, not coming on the stage.
Hello.
Hello. So, basics. How much it costs to get one of these?
Well, you can get it for 100 euros per month.
It's subscription business
yes,
model.
Yes. And starting from July, I think.
Yep. We have 3 prototypes available right now for early adopters, so come and find us and we'll bring it to your office.
100 euros per month. Yeah, sounds awesome. Investment
Affordable.
agency, Riga City Council, are you already like skin in the game, supporting ecosystem? So, cool. And you're looking now for scientists and engineers, right?
Yes.
And money.
How much?
A lot.
What's a lot?
There are no limit to what we are willing to achieve.
All right, like 500,000?
Yeah, we can work.
Yeah, we can work that. All right, let's catch up afterwards. Any questions? Yeah? Microphone.
Sorry. How big area can you use this for? Like one of these prototypes? How many square meters?
For around 60 square meters. Yeah. We started with smaller spaces where few people work, up to 7 people, but now we are improving the aeration system so we can increase the people in the room. Yeah.
How you measured that?
By the air pump, the speed of the air pump, and how much person exhales of CO2 per day.
Have you tested it with Aranet?
Yes.
Yep.
Okay.
There's a lot of data involved in measuring.
Okay. Yeah, of course, I can imagine that.
Yeah.
We also have CO2 sensors on the main panel. You can see it in the picture.
But if I want, like, screw it, I want to purchase this, how much it costs?
We are not selling. Yeah, we are not
we'll
selling.
Have to talk afterwards.
Yeah.
There have been inquiries before, so we're open to these conversations as well.
Kate is a salesman. Okay.
I had a question regarding application towards like sports or cultural center where there usually is lots of people meeting in a short period and there is no air at the end of the event. Not here, but in the schools or sport halls. Have you been thinking about that area of development product? And if yes, then I guess Riga City Council would be interested to test somewhere in this, which would be related to this kind of application.
Yes, we have been thinking about schools. However, it's a bit hard to put it there because of a lot of children and parents and
safety issues.
And yeah, safety issues.
It's quite pricey as well.
And also we need to make it modular. So when the room gets bigger, we can just add modules to it. So expand the area it purifies.
Yeah, that brings me to the question, how long it takes to generate the oxygen? It's not like you're going to put it here and just like, oxygen.
No, well, as algae grows, it generates the oxygen, but it's more like during the day it generates some part of oxygen and absorbs CO2. And the more it has CO2, the more oxygen it can generate.
Okay. Cool. Time for a quick question? Yeah?
Thank you.
No, that wasn't like, I let you go now. So, to finalize water section, we have NLab, autonomous platform for industry and research. Good, you are excited about yourselves. That's a good start.
We are NLab, and this is IRAF. We are the team NLab, which is a creative platform that brings together industrial designers, extreme environment architects, robotics and electronics experts, with the aim to develop innovative robotic solutions. NLab testbed, or a water box, is the first water polygon in Latvia, created as a unique place to study, to test, and research for innovative solutions related to the water. We are based here in the middle of the center of Riga, in the middle of the river Daugava.
We are modular gadget. Our device can be scaled from 1 to 1 till 3 to 3 meters in size. The main features of our platform are teleoperation and autonomous moving. We try to build a platform which is necessary for a lot of businesses. We can solve pollution things with retrieving some nets. We can also deliver something by the water.
The program was not just opportunity to get budget for our final prototype, but it was great opportunity also to meet great people, new teams, also to get feedback from the mentors. And we really enjoy a lot of lectures by 2 dots in a business study. In the period of the program, in the 5 months, we made a lot of interviews and made great research. And in the end, we came out with a 5 use case. Our platform can be used, and they are commercial harbors, hydrogen infrastructure engineering service, water researchers, industries like fish farms, and of course security and defense.
Future ambitions are to have a more advanced and upgraded prototype, heading towards the next TRL level. The work with the potential users, future users of this IRAFT autonomous platform. We are going to Ventspils port, we are going to Riga port, we are talking to municipalities since they're having aquatoriums which needs to be observed and explored, and we are trying to find use cases, solve them, and offer a tailor-made solution for them.
A big team. Who is the most talkative? Not giving you the mic. So, you also look optimistic. That's good. So, you mentioned the industries, but what's like a typical, what would be the typical use case for this one?
At the moment, we are working closely with hydraulic engineers that inspect water dams and water infrastructure. And actually these 5 industries, the others are, for example, ports, fish farming, what else?
Security, defense.
Yes, one of the things I'm quite happy about what we achieved in this program, from the very beginning, we worked closely with these specialists from industries, and then we developed the idea, the prototype, and actually to try to solve the design solves something for the industry, and not only building exciting floating gadget.
What's the business model? How you work with this? You're not talking about that.
Yeah, that's a different department. So the business case is, just as said, is a special tailor-made solutions that we can solve for the end user, like municipality, for instance, some safety departments, ports, engineering companies doing the observation of hydro infrastructure objects. So, and this is a platform that could be equipped.
So you also provide the service.
Different devices. We are focusing on developing the platform itself that can be adjusted with different gadgets doing specific tasks. So actually there could be like 5 different sales departments doing, so each of whom solving different problems.
But how much?
What is how much?
Like I need that thing for a week.
Well, if you take today, we can give you for 20,000, but so tomorrow. Okay. Well, you take today.
The true salesman.
The first prototype, I think it has already like design value into maybe some design museums want to buy it, and so we can actually sell it for more. No?
Hashtag optimist. Questions from audience? Oh, come on. So, what's next? What are your plans for upcoming months, and what are you looking for? What do you need?
So, what
Different
next?
department again.
Yeah. So, what next? Next is to get a great celebration in Midsummer Fest, and then go out after Peter Festival. We will jump in our partner test. So we already have booked all the jewel in different places. Like colleague Chris told, it's a government area, different lakes where we want monitoring the water quality. As well, we are going to Riga Harbor and also to Ventspils Harbor to monitoring different things.
Are you competing with that water?
No, we are partners.
Okay.
Already.
Your friends, besties.
Yeah.
Okay. Now, any questions? No.
If there still 1 minute, if there, I just wanted to mention we are very glad to see you all here on this floating platform where we are now. This is the place where we are best and where we developed iRaft, and I welcome other people to join our water test bed. We call it water box, and I want to see more and more ideas floating around the river.
All right. Will it be possible to see it in action later today?
Yeah, we are present.
Yeah.
Yes.
Demo department will deliver later. So, thank you. So, how did you like it? It's actually a bit better than in the morning or at the beginning. Like you're getting warmed up, but that's good. So we are having a break now for around-ish 20 minutes. We'll be back sharp at 2. Yes.